I'm Professor Watson, and welcome to the course guide for Machine Learning CS 156 at Minerva University. This year, I'm revising the course, and I'm going to make an outline to give you a high-level view of what's going to go on in the course as we work through the year. To give you a little idea of the outline that we're working with, I'm going to talk to you today in this first video about why you shouldn't take this class, or why it's probably not a good idea to do machine learning. The basic framework that we look at when we're doing machine learning project. What are the basic tools and how do we put them together? Then I'll finish up with a course outline that tells you how we're going to go through the course over the course of the semester and talk a little bit about the class culture and what we'll do day to day. This will give you a general lesson zero. And by watching these videos, you'll be prepared to at least start working in the class. We'll do a couple of days where we cover some of these topics in more depth, and then we'll move on to specific algorithms and architectures. But I really wanted to pause and get this level of understanding, because I feel like a lot of students come in to machine learning and they're really excited about AI, and they're really curious about machine learning and about what it's going to be like. They are excited to get jobs in the industry. They know that it's a very well remunerated position and they want to make money doing it. And they are driven a little bit by a social image of the job, or maybe a better way to say that is to say the prestige. So it's a cool job. It's a cool idea, and they want that social cachet. And I want to start out by saying probably won't get any of those needs met in this class. So I really love this meme that I found about artificial intelligence, because this really does sum up the experience of a lot of people who actually make the plunge to get into doing machine learning for the first time. They say, hey, artificial intelligence, why do you always wear that mask? They peek under the machine learning mask and it's just statistics. And then they usually do this thing. They say, let's keep this on, and then they bounce. And that's okay. It's not a topic for everyone. It's not super fun and exciting. The curiosity that you bring to this and the excitement that you often walk in the door with comes from hearing all of these stories of machine learning rather than the actual day-to-day nuts and bolts. Like any job, like any technical area, when you get into working in the nitty-gritty details, it rapidly gets a lot less fun. It rapidly gets a lot harder. And it rapidly means that you'll be doing a lot of low-level statistics, grinding through, reading math books, spending hours staring at equations, trying to understand what they're doing, calculating gradients, writing difficult code. It's not a lot of fun. This isn't to say you can't do awesome stuff with it. I just spent last week, I did this amazing art project where I used VQGAN and CLIP, which are some image generation neural networks, to make art for my piece. I can't draw, but with machine learning, I can. And so I was able to use that. Super cool, super enjoyable, super fun, super worth knowing. But I do just want to say, hey, probably you're not going to get your curiosity met right away, right out of the box. It's not going to seem exciting. It's not going to seem fun. It's not going to be robots. It's going to be math. And if you're here exclusively, if you can't understand if you can't make that bridge from math to doing those cool robots, it's probably not going to be your favorite thing. The second area here is the jobs area. And this, I would say, is this class is absolutely insufficient for you to get a job in machine learning. And indeed, every class is absolutely insufficient for you to get a job in machine learning. The people that you see who are very well recompensed, who do things like fintech, who do things like build the image recognition software that works for Google to how Google knows that this is your face and groups your photos that have all the ones with you in it automatically, are all of those jobs, all of those technology systems are typically built by people who have 15 to 20 years of experience in the area. It's not impossible for you to become such a person by taking this class. It's just that it will take 15 to 20 years, and that's okay. That's how long it took me. I was actually in undergraduate. I started working on neural network learning, and then as part of my neuroscience degree, and I really got into it, really got into the mathematics behind it, went to graduate school, did computational neuroscience, did a postdoc doing computational models and machine learning models for neuroimaging data. Later on, went to IBM Research to work on AI for education, where I built a number of models that worked on detecting learning over time. And then worked in AI for industry, where I built a lot of neural network-based representations of things like automated factories. And by the time I got there, and I still don't feel confident. And so by the time I got there, by the time I got to my capstone, I've been doing this for many, many years. And that's because it's very, very hard. I promise you, you don't need to do machine learning in order to be really well recompensed. If you spend 15 years learning math, someone will pay you for it. It's hard to be poorly paid if you spent 15 to 20 years. And so I think that a lot of that comparison of I want to get a job in this area, I want to be successful, begins from a place where people have seen people who have been out there working in the industry for 20 years, and they're making a comparison. They say, I want to be like that person. And I want you to be like that person. I want you to get there. I'm doing this class in part because I want to conduct people there. I'm just saying it's a much longer road. And looking at the end of people who are, working in their careers, who are very well established, and thinking that this, one semester is going to prepare you for that, it's not true. This one semester will put you on the path where you can start working in that direction. And in 10 years, who knows? So again, probably not going to prepare you for a job. And lastly, the social prestige. It's a cool, exciting, fun job to be, you're working with robots, you're working on computers, you're automating the world, right? You're doing all this cool stuff. In general, that is, I found, very overblown as someone who has worked in the industry, that I was never prestigious when I was building the models. That the person who was prestigious was my manager, who was selling me to the clients, that they would go around and they would tell everyone, hey, look at this incredible genius, which I was not, and who knows about machine learning. He can solve all your problems. I can't solve all your problems. And that's all marketing. And so I fear that a lot of this prestige that people associate with the machine learning profession is mostly advertising. And in this class, there'll be no advertising. As you can probably tell from this little video so far, I'm very bad at advertising. I started out my class by saying why you shouldn't take this class, by saying why it won't fulfill your curiosity, where it won't get you a job, and it won't make you prestigious. And that makes me a very, very poor marketer. Instead, I'm a pretty good machine learning instructor. And so what will happen in this class is that I hope to give you access to a lot of the really powerful and beautiful mathematics that underlie it, that give you a lot of practical, concrete experience in actually developing and building machine learning tools, and that give you a peek into the behind the scenes culture that underlies a lot of machine learning. Machine learning is actually a very interdisciplinary, very complex topic that draws on places like cognitive science. It draws on places like computer science, statistics, even off the wall things like video game design that all work together, and that any expertise you have can be brought to bear on this topic. But very often that culture of that history that really frames machine learning and explains why we did all of these things in the first place is fairly hidden, because it is something that is, for a couple of reasons. The first is that it takes place with a lot of reliance on people's past history and past connection to the discipline itself. So they sort of expect people to look a certain way, to be a certain race, to have a certain background, male, went to a good college, that sort of thing. And it is a little bit one of the ways in which that uniformity and that cultural narrowness is reinforced is by failing to just talk about the cultural background. You're expected to know the vocabulary. You're expected to know the critical experiments and the critical test cases. And I'm not going to assume that. I'm going to try to, at best, examine my own assumptions and my own background knowledge and explain things in terms that I think are more accessible. So I really wanted to make that a huge component of this class. So not only will you learn the concrete material of it, I hope to also let you into the skill of machine learning and the culture of machine learning. And I'm going to talk a little bit about that in the next video. So thanks for listening, and see you there.